This video covers some basic biotech tools used for measuring and metric conversions. So here there's just a little Calvin and Hobbes comic about the importance of units. Okay. What I would like you to do is go into your notebook and title your next blank notebook page Biotech Tools and Metric Conversions. Number the page, initial and date, and put it in your table of contents just like usual. Make sure you're using a blue or black pen. You may want to pause the video for a moment to give yourself time to do that. Once you've got your page all set up and everything's organized, we're going to talk about the metric system today and about how all of the measurements that we do in lab are based on metric measurements. I just thought this map was interesting. So the red countries are countries that do not use the metric system in any way. Right, so the US is one of few countries that does not use the metric system. Because so many other countries use the metric system, we are going to use metric measurements in science because it is important for units to be standardized.
Measurement. A long time ago, people used to measure things with their own body parts, like feet. But just whose foot was 1 foot? Later, it was the king who declared that his foot, the royal foot, would be the foot that all feet would be fitted against. It was the standardization of the foot, and it was quite a feat.
Humans are about this big, so we've always wanted a unit of measurement about this long. And we want it to be the same for everyone. We want it to be a standard. That's why it's hard to use something like a foot, because not everybody has the same size feet. So what we did is we looked at the Earth and we divided the distance from the North Pole to the equator in 10 million times. And we got this. It's a meter. We use tens because humans have 10 fingers. Now you can keep going. You can divide a meter by 10 and 10 again, and you get centimeters. There are 100 centimeters in a meter, just like there are 100 cents in a dollar. You can divide it by 1,000, and you get millimeters, by 1,000,000, and you get micrometers. It's easy. With a meter, you can measure just about anything. This microphone is about 32 centimeters long.
What?
It's the metric system. It's easy.
What?
I said it's easy.
What?
Great overview from Bill Nye about the metric system and why it's important to have standard units. Here's another example from not that long ago, a little while ago, from the late 1990s. NASA was building a Mars climate orbiter. Right, so it was going to be sent to Mars. It cost a ton of money, right? A huge amount of research went into developing this probe and building it. But unfortunately, the probe burned up in the Martian atmosphere upon entry. Right, so there was a review board that was convened to try and figure out why. And what they determined is that one group of engineers was using metric and the other was using imperial or non-metric measurements. Right? And so the two groups thought that the other was both doing the same thing as them, but they were actually doing different things. So the measurements for the building of the probe were not quite right? Because they were using mismatched units. And so this caused a navigation error, and it caused the spacecraft to go dangerously close to the planet's atmosphere, where it burned up and broke into pieces. So the mission was a complete failure because those two groups of scientists did not use the same standard units in their work. All right, so what are these standard units? So the standard international units that should be used everywhere by scientists are called SI units, or Système International. It was developed in France. Okay, so the base quantity for length, the unit is the meter, symbol is a lowercase m. For mass, it's the kilogram, or kg. You can also do grams. For time, it's technically seconds, but minutes and hours can be used as well. Amount of substance is the mole, which we'll talk quite a bit about in a few weeks. And thermodynamic temperature is Kelvin, although we will be using the accepted alternative, which is degrees Celsius for temperature. You'll notice there's one unit that's not included in those base units, and that is volume. Volume is a unit that we will use all the time in biotech to measure. You measure liquids with volume, and volume is basically the amount of space a liquid takes up. It's not one of the base units because it's derived from length. It's length cubed. We don't really need to worry about that. But we are going to use volume quite a lot. The volume units in the metric system are milliliters, microliters, and liters. Okay? And we're going to talk just briefly about some of the tools you will use in the biotech lab to measure these things. Okay, so if you're measuring a big volume, you're going to use either a graduated cylinder or a beaker. There's some pictures there of what those look like. Okay, the range of volumes you'd use these tools to measure would be anywhere between 10 milliliters and 2 liters. So large volumes. Okay, you can think of like a 2-liter soda bottle, right? That's 2 liters, the big ones. If you're measuring a medium volume, medium for science, you'd use a pipette with a pipette pump. So it's a long glass or plastic tip attached to a pump that can measure between 1 and 10 milliliters. If you're measuring a really small volume, which we will do often in the lab, you'll use a micropipette. Okay, these are these fancy handheld tools that have the smaller plastic tips on them. With these, you can measure between 0.5 microliters and 1 milliliter. So it's really important to understand what is the difference between a milliliter and a liter, what is the difference between a microliter and a milliliter, microliter and liter, right? What are these different units and how are they related to each other? All right, so let's talk just a little bit about some math, and particularly unit conversions. In this class, you will need to be able to convert between liters, milliliters, and microliters. All right, so liters are the largest unit of volume we will be working with. So they are the biggest of all of these units. Milliliters is the next largest, and then microliters are the smallest that we will work with. There are other units like the kiloliter, that's even bigger than a liter, but we're not really going to worry about those too much. So we're focusing mostly on liters, milliliters, and microliters. Liters are the largest of those, then milliliters, then microliters. And in biotech, we have a simplified form of conversions. You may have learned something a little more advanced in some of your other classes if you've taken chemistry, but we're going to keep it really simple here for biotech. And we are going to use one of my favorite biotech rules, the BS rule. So we're going to do a little BS here, so bear with me. Here's the idea with the BS rule. If you are converting from a bigger unit, which is what the capital B stands for in this little diagram here, to a smaller unit, which is what the S stands for, you move the decimal point to the right. So following the arrow that you see there in this little diagram where it says rule. So from bigger, capital B, to smaller, you move the decimal point to the right. If you're going from a smaller unit to a bigger unit, you will move the decimal point to the left, like the arrow shows in the diagram. Okay? In biotech, you will always move the decimal point 3 places for a unit conversion. We are doing very simple conversions in this class. We are not getting fancy. So always move the decimal point 3 places, either to the left if you're going from smaller to bigger, or to the right if you're going from bigger to smaller. Okay, and this little chart tells you which are the bigger units and which are the smaller units, so make sure that you write this down. So for instance, if you're going from 1 liter, and you want to convert that into milliliters, so you can use, say, a milliliter graduated cylinder, right? You're going from a larger unit, liters, to a smaller unit, milliliters, so you move the decimal point 3 places to the right, following the arrow in that diagram. Okay? If you are going from microliters to milliliters, microliters is a smaller unit, milliliters is bigger, so you're going from small to big. If you look at that diagram, the arrow from small to big points to the left. So to go from microliters to milliliters, you move the decimal point 3 places to the left. Okay? So here are a couple of examples of that. All right, let's take a look at some practice problems. Okay, so here are some different volume conversions that you might need to do in this class at one point or another. So let's say I've given you a volume in milliliters, but the only tool you have to measure it measures in liters, right? You'll need to do the conversion using the BS rule. Okay, so if you have 93 milliliters and you want to convert to liters, the first thing you want to think about is the BS rule. You can always draw it on your paper anytime you're working this kind of problem out. It's always the same. You put the B first, BS, right? Put the S second, draw the arrows in between them. And then you've got to determine which unit is bigger and which one is smaller. So milliliters is a smaller unit. Liters is a bigger unit. Excuse my handwriting, sorry. Right, so you're going from a smaller unit to a bigger unit, which means that you're going to need to move the decimal point to the left. And in biotech, you always move it 3 places. Okay, so 3 places to the left, you go 1, 2, 3, right? You got to fill in that 0 there. And then you can write that out. So your answer here would be 0.093, right? So 93 milliliters is the same thing as 0.093 liters. I put a 0 out in front here, a placeholder 0 out before the decimal point. That's just sort of convention. It's not wrong if you don't put it, but it's just sort of the way that people usually draw things. Okay, if you need to convert from liters to milliliters, say you want to measure on a pipette, right? You're going to take this and you're going to look, okay, is liters bigger or smaller than milliliters, right? And in this case, liters is bigger and milliliters is smaller. So you're going from B to S. So you're going to move the decimal point to the right. You're going to move it 3 places, right? So you're moving it to the right 3 places. So 1, 2, 3. It ends up right here. So what you get is you get 15 milliliters. Okay? All right, the next one, milliliters and microliters. Okay? Milliliters is bigger, microliters is smaller. So again, you're moving the decimal point to the right. Right? You want to move it 3 places just like usual. So you're starting here and you're going 1, 2, 3. And you got to fill in all 3 of those zeros. Sorry for my handwriting. There we go. So what you get is 27 and 3 zeros, so 27,000 microliters. All right, 1.5 microliters to milliliters. Microliters is smaller, milliliters is bigger. So referring back to our diagram, if you're going from smaller to bigger, you're moving the decimal to the left, always 3 places. Okay, so you'll do 1, 2, 3. Okay, you fill in the 2 empty spaces with zeros. And again, you put a placeholder 0 out in the front, but then you fill in 2 zeros there and 1, 5. So a very small number. And last but not least, if you have 750 microliters going to liters, this is a big jump. You're not just going from one spot to the next, right? So you've got liters, milliliters, microliters. My micro is kind of hard to follow. Sorry, give it a long tail to make sure you know it's micro. Okay, you're going 2 jumps, right? So it's 3 decimal places from here to here. Or, well, I guess the other way. Right, 3 decimal places from here to here. So you're going a total of 6 decimal places, all in the same direction. All from a smaller unit to a bigger unit. Okay, so from smaller to bigger, you go to the left. 6 total decimal places, 1 for each of these jumps. Okay, 1, 2, 3, 4, 5, 6. Okay, so you basically have to fill in 3 zeros here. You get 0.00075. You can put the last 0 on there if you want, doesn't matter. Right, and a placeholder 0 out the front. All right, that is doing practice problems of volume conversions. The other type of measurement you'll do often in this class is to measure mass, and you've already done this some. Mass is a measure of how much matter or how many particles an object contains. There are 3 main tools of mass measurement in the lab. There's a triple beam balance, which is this one on the left. We won't use that as much in this class, but if you take chemistry, you may use that more often. Then there's the tabletop balance, which is very similar to your small pocket balance that's in your lab kit. And then on the far right, there is the analytical balance, which is the fanciest of all of them. All right, so for your pocket or tabletop balance, you have more or less already figured out how this works, right? This measures up to 0.02 grams of accuracy. So it can be accurate to 2 decimal places, more or less. Right? And some of the balances in the classroom have 3 decimal points in them, but they're still tabletop. That last 3rd decimal point is an approximation. Okay, but if you see 2 decimal points, those first 2 decimal points are the ones that are accurate. Pocket or tabletop balances should be used for measurements that are large or measurements that have 2 or fewer decimal places. You should not try to use this balance for something that has a whole bunch of decimal places at the end of it, because you're not going to be able to be accurate enough for that measurement. But most of the measurements you'll do at home will be 2 or fewer decimal places. Okay. If you need to measure things more precisely in the lab, you will use an analytical balance, which are the fancy ones with the glass box on top to try to make sure that everything stays very accurate. Analytical balances measure up to 0.001 grams of accuracy. They can go lower. They can go more precise than the other balances. Okay, so in these balances, there are 3 accurate places past the decimal point, and the 4th place is an approximation. Analytical balances should only be used when you are making measurements that are small, so less than 0.1 grams, or if there are many decimal places that you need to measure accurately. We will only use these once we're back in lab, so you don't need to worry about this for now, but analytical balances are for smaller masses or ones that you want to be especially accurate. So now let's practice some mass conversions. So often when you calculate things in this class, you'll get an answer in milligrams, but you can't actually measure milligrams on your balance, right? You always want to measure in grams on your balance to make sure you're staying consistent. Or you might get something in micrograms when you do some math and you got to convert it, right? So we're going to practice these conversions. Okay, let's just keep in mind, oops, that's not going to work. Let's just keep in mind the order of sizing. So bigger units, you're going to start with kilograms as the largest one shown here, and then grams, and then milligrams, mg, and then micrograms, which are sometimes put as a u and sometimes are this Greek letter mu. Okay, so bigger to smaller. All right, and I always like to write in the BS rule, right? So if you're going from bigger to smaller unit, you move the decimal to the right. If you're going from smaller to bigger, you move it to the left, and you always go 3 places. Goodness, I got to practice my drawing here. Okay, so milligrams to grams. The first thing to figure out is which is the bigger unit and which is the smaller. So you can consult the chart over here. Grams is bigger than milligrams. So grams is the bigger unit, milligrams is the smaller. So if you're going from the smaller unit to the bigger unit, right, smaller to bigger, move the decimal point 3 places to the left. So it starts here, 1, 2, 3, and you fill in that 0. So you've got 0.075 grams. Sorry about my drawings. Right, placeholder 0 out in front. Okay, now if you're going from milligrams to micrograms, this time milligrams is bigger, right? And micrograms is a smaller unit. If you look at the scale here, right? So milligrams is bigger, micrograms is smaller. So if you're going from bigger to smaller unit, right, you're moving the decimal point to the right. Okay, so 1, 2, 3. You got to fill in a 0 there. You've got basically 450. So 0.45 milligrams is the same as 450 micrograms. All right, 758 micrograms to milligrams. So this is the opposite, right? You're going from the smaller unit to the bigger unit. So from smaller to bigger, if you consult your diagram, you move the decimal point to the left. So it starts here, right? Always starts right after the last whole number. 1, 2, 3 places, right, to the left because of the diagram. So you get 0.758. Gotta get myself a better mouse. Oh well. All right, kilograms to milligrams. All right, this is 2 jumps, right? Kilograms to grams and then grams to milligrams. So this is another example of moving the decimal point 6 total places because you're doing 2 jumps of 3 decimal places. All right, kilograms is a big, big, big unit. Milligrams is much smaller. So you're moving the decimal point from big to small, so to the right. And you're going to move it 6 total places. Okay, so 1, 2, 3 for the first jump. 1, 2, 3 for the second jump. So you're basically filling in, it's hard to see, sorry. You're filling in 4 zeros, right? 1 for each of these spaces. So it's basically 8 and 4 zeros after it. 8,000 milligrams. So 0.08 kilograms is 8,000 milligrams. All right, last but not least, another one that's 2 jumps. So from micrograms to milligrams to grams. So 6 decimal points total. But here you're going from the smaller unit to the bigger unit. So from smaller to bigger, you're moving the decimal to the left. And you're going to move it a total of 6 places. So 1, 2, 3, 4, 5, 6, right? And all of these that don't already have a number in it get filled in with the zeros. So 3 zeros. There's your decimal point. So you've got placeholder 0, and then 3 zeros, 3, 9. put the last 0 at the end if you want. It doesn't really matter. All right, and those are our practice problems. All right, go ahead and pause the screen once I've finished these directions. You're going to be copying these problems into your notebook and solving them in your notebook. All right, so go ahead and pause the screen on these problems and solve these in your notebook using the BS rule. And here's one more set of practice problems for mass. So again, you're going to go ahead and copy these into your notebook and solve them. I would recommend pausing the video here.